Hello everyone and welcome to ARP Powered by ArcNC for Panasonic training. This training is going to take place via a short section of videos, which you'll be walked through first the signing up of the ArcNC tenant and then walking through how to use it. So if you have just received your tenant for the first time and this is your first time having access to the tenant, you're going to land on a page that looks like this. In this case, this is the Valk Welding demo tenant. So as a customer, your customer name will appear here, and it's your job to sign up to the tenant. Now, when you land on the tenant page, you will actually land on the login page. So if you're going to sign up to the tenant for the first time, you need to click first on the sign up box. So when I click on the sign up box, I can fill in my email. Mine is automatically filled in here because I already have an account. But if it's your first time, you need to sign up using your work or company email address. You will have been given access to the tenant already, so you can sign up with your work address. Once you click continue, it's then going to ask you for a password. I obviously already have a password because I have access to this tenant already. So it will also check for you what the requirements are for the password. So you need, for example, an uppercase, lowercase letter, numbers, and special characters. These are all relatively standard requirements for a password. But in this case, I've already got an account, so I don't need to go first to the login, to the sign up page. I can go straight to the login page. So once your account is set up and you've clicked sign up, you will receive an email in your work email with a link to verify your account. You first need to verify your account via this link before you will have access to the tenant. In this case, I can now log in after verification of my email. So I can click continue. My password will at this stage be automatically filled in for me because, as I said, I already have access to the tenant. And once I click continue, I will be logged into the ArcNC tenant over here. It's busy logging me in, and you'll arrive at the landing page of ARP Powered by ArcNC. This is the landing page. On the left, you see a bunch of tabs, and in the center, you have the main platform. So now a small walk around of how the platform works. There are a couple things you can do around here. On the left, you have your navigation panels, and on the right, you have some filtering panels. So if I go, for example, to my part models tab, this is where you're going to upload step files and your part models to create a program. You can see I have none available here, but if I change my time range to, for example, the last 30 days or even more, you can see all of the part models that I've programmed inside this platform. I will filter to today so we don't have a nice long list. On the left, you can see that's the Define Part Models tab. This will be the tab that you use absolutely the most, and this is where you need to go when you want to upload a part. If I go to the users pane, you can see who the users all are of this platform. It will be, in this case, only your employees or your colleagues. If you go to customers, you're able to manage the customers that you are welding for example. That will become a little bit clear later in the training. Categories, you're able to create categories for your parts, for your tools, and for all kinds of things in here. Again, they're not going to be used a lot, but they can be used, and there'll be more explanation on that later. Once I go to configure cell models, here you will be able to see the cell models that have been set up inside the tenant for you. So we will have already set up the customer tenants for you. They are Valk Welding machines. And inside here, for example, if we take a look at the track E frame, which is the cell we're going to use in the training today, and I click on edit design, try not to edit anything inside here because it's usually set up including calibration values and all of the files should be good. So this is just for you to see how, for example, the cells are set up. This can take a little bit of time to load in as the files are being downloaded from the Google servers, from the cloud. And then you can right click to navigate around. If you zoom in with your scroll wheel, that's for zooming in and out. And if you want to pan around, for example, to the left, you can click in your scroll wheel, and that is how you can move around. There's another way to do that, and that is if you use the Shift key on your keyboard and then right click, you're able to also pan around, and Control right click will pan around the point that you click on. That will become much more useful when you're programming part. These navigation methods are universal across the platform. So during programming, in cell model, in JIG editing, it's all universal across the platform. So I'll close that over there. Then under material models, This is the type of wire that you're going to be used. In this case, I only have one type of wire set up in the platform. That is steel wire 1.2 millimeters. If you're welding with different types of wire and you want to categorize your parts by the type of wire that you're using, you first need to create a material model, and then you can create different types of wires. This can be useful for people, for example, who are doing steel wire with 1 millimeter, with 1.2 millimeter, maybe aluminium wire. That can all be set up inside this section over here. If I go to the tool models, this is where you're going to set up JIG models. So JIG models will get uploaded as a separate step file to your part models as a separate step file. And again, this will become clear in the next section when we go how to upload a part and how to create a JIG. So now we've decided we want to weld a part. So at this point, we need to create a JIG. So the first thing maybe before you create a part is you need to upload a JIG model. So you need your JIG model defined as a step file or an STL file. These are the two types of files that are allowed to be used for JIG parts for the CAD models of your JIGs. So if we come over here and we come to the tool models tab, we're going to now create a JIG. If I click on create tool model over here, it says you want to create a tool model. So this page pops up on the window on your computer. And the very first thing we're going to do is look at a name. So for example, if I say here, I can normally say, I want to create Valk Welding Training JIG. That is now going to be the name of this JIG going forwards for the rest of time. So you can always change it later at a later stage, but this will be the name of the JIG for now. You can give this JIG a type of category. Normally, I will give all jigs and clamps the category JIG and clamp. That makes it easier later to find that back. And if you ever want to create a category, it's as easy as typing, I want the category to be training. And you can always just click create training, and then you're going to create a category called training. In this case, I would rather have my JIG and clamp with the type JIG and clamp. There's no need to put any notes or attachments, but you can if you like. For notes, you can just type any notes that you like about this JIG. And for attachments, you could attach, for example, a PDF file for a drawing of this JIG if needed, but for the most part, that's not necessarily used. Under geometry, this is where you're going to upload the geometry of your JIG file. So here you see it says upload step or STL file. Now, if I want to upload a step or STL file for my JIG, I can click on the little upload button here with the cloud or just anywhere in the middle here. So if I click, I'm going to get a pop-up which says you can now upload a JIG. Here I have a step file. This step file is then going to be the file for my JIG itself. Once I click open, you see a little wheel go around to show you how this part has been uploaded, and I can click create. This JIG is now created. So this is done. This JIG is completely contained inside here. The file is uploaded and processed, and the JIG is ready to use. If you ever want to see what the JIG looks like, you can click on Edit Design. And then when you click on Edit Design and take a look in here, you will see your JIG. In this case, I've just uploaded a random step file. So it's not necessarily a JIG, but the process is the same. So now the next step that we've created a JIG, we of course now want to upload a part, and we want to start the programming process. So if I come over to the part models tab, so I'm changing over from tool models to part models. Once I click on the part models tab, we're now in the right place to upload a part, a file, a step file. So when I click on create part model at the top and I create part model, again, a window is going to pop up for you for uploading your part. The type is always going to be 3D geometry because your part is going to be uploaded as 3D geometry, which is a step file. The requirement for a part at this stage is step files only, so you can only upload a step file. The name, I wouldn't worry about the name for now. Your name will carry over from the name that's contained in the step file itself, so you can leave that for a second. And under customer, you can now decide if you want to weld for a specific customer. So in this stage, we'll just use the customer training. But you can see I have a list of customers in here. Let's say I want to weld a part for Valk Welding. I can simply type Valk, and you'll see I have two customers. That's Valk Welding and Valk Welding Ireland. So for example, here we could say, okay, we want to weld a part for Valk Welding. But actually, I would like to keep it in the category training at this stage for the customer training. Material model, again, I showed you earlier how you can set up different types of wire, different types of material that you're going to weld with. In this stage, we'll take steel wire 1.2 millimeters. Now, root model, Route model is how you're going to decide which cell you want to weld in or which cell you want to program in. So it's important at this stage to know which specific robot on your production floor you want to program your part with, just like in DTPS. So under route model, in this training, we're going to use the demo track E frame. That is a standard Valk welding cell. It's a track E, so it's robot on a track with some manipulators, and you'll see that in a second. Once I click the upload files button, again, a pop-up box is going to appear, and here we can then select the step file that we want to use for the programming. So I have ArcNC demo part.step. This file is accepted by the platform, so I click open, and it opens up and you get another window. You can upload multiple step files to create multiple programs at the same time. So if you were to click upload files again, you can upload more files. You can also, for example, I can upload the same file again, and then I should have two. And maybe I want to weld the second one in a track Y frame. In this stage, you can create multiple parts at the same time, and then the parts will be created in the platform, and you can create programs for each of them individually. You can also delete. So for example, we're going to just make one part and one program at this stage. So now I have created, or I will create, only one program. So once I click create, I'm then going to create a part model. This part then gets uploaded to the cloud. You see it's processing 1%. So the part's busy getting uploaded. But if we have a look at the bottom here, you can see information about the part that you've uploaded. So the route plan, you can directly see which cell you're going to be welding in. And you can see there have been no revisions. This is the first version of this part, so it's revision number 1. At the bottom, there's some information. You get a unique part number. This is the 60th part, for example, that I've uploaded. And you can see a bunch of data about what you've uploaded. If you ever want to download the step file that you uploaded, you can do that over here. And then you can see there's the part that you uploaded. So if you ever look back and say, wow, what step file did we upload for this program? You can find it back over here. So coming back to the top, we get a quick view of what part we've uploaded for welding, for programming, and you can see that directly over here. All right, now we've created a part model, so we want to begin the programming process. So the first thing I'm going to do is I'm going to edit route plan. Once I click edit route plan, what the software is going to do is open up the welding cell that you've decided to weld in, and it's going to upload the part and both of them inside. So we're going to give it a second to download all the installation files into our browser, and then you should, in a second, have everything contained then inside your window. Once again, right click is to pan around, to rotate around, and clicking in your scroll wheel is to pan around. Now you arrive at this screen over here. So it's called the setup screen. So of course, this is where you're going to do a bunch of setup. And at this stage of the training, we're going to look at placement. So now we need to know where we're going to put the part, where we're going to put the jig, and the two should come together to be an exact copy of what you have in the real world for the real welding situation. You can see there's some processing already taking place on the left in your program window, but we can ignore that a little bit for now. So under setup, the first thing I'm going to look at is I want a jig. This doesn't really make much sense with this part floating in the air here. So I'm going to add a clamp and jig. And under add tool model with the little plus, I'm going to choose which jig I want to add in. All my jigs in existence will appear here. And for example, I just want a standard Valk welding clamping beam. So that's my current name for the clamping beam, and you'll see what it is in a second. So once I click add tool model, the clamping beam will get added inside the installation. So now you can see this is really a standard Valk welding part, which is the clamping beam that gets mounted to the rotator, and that's then inside your installation. This is now going to be a collision object, so the software will make sure not to hit this clamp or jig. If I want to know a little bit more about it, I can click on it and I get some more information here. You can give it a different name for this program if you want, and you can decide which parent you want to attach it to. So in this stage in the Valk welding cells, the G4 is the track, the G5 is the first rotator, and the G6 is the second rotator. So for example, if we wanted to program in the second cell, so in the second workstation, I can say attach it to the G6, and now my clamp or jig is going to be attached to the second rotator, the G6. We will be programming in station 1, so I'll leave it in station 1. And the next thing we can look at is transformation. So if I click on the show box here, we get some ways to move this clamp or jig. So for example, if I want my clamp or jig to be 1 meter spaced away from the robot, or 0, go back to 0, or 1000 millimeter, 1 meter to the right, or maybe I want to go 1 meter to the left, there will be situations where you need to move your jig. I can do that over there. And of course, I can go up in the Z. And of course, we also have rotation. So if I were to rotate this in the X, you'll see that it gets rotated 90 degrees around the X axis, and then that goes vertically up. That's again, not useful in this case. The orientation of this jig is good for now, so we're going to leave everything at 0. Now, if you look at home configuration, there's nothing inside here because this jig doesn't move. It's a one-piece jig. And if I look under collision padding, you can see how much collision you want to add. So if you want to fatten your jig by, say, 5 millimeters, just to be sure you don't hit it, you could add 5 millimeters here to make sure that your jig is fattened by 5 millimeters during the collision process to make sure that it's not going to hit there. I'm going to leave it on 0 over there, so I can collapse that again. There's some other settings we can do here. These are some motion planning settings. These settings here are your standard settings for the collision object and how the software is going to be sure that you don't collide with the part or jig. So the maximum stick out offset, when you're programming, the software is allowed to add 6 millimeters of extra stick out in this stage. That will only happen in really tight corners where, for example, the gas cap would collide with the part. And our standard is 6 millimeters. That's something we tend to stick to. And the maximum work and travel angle offset is how much the torch is allowed to deviate from the preferred welding position during programming and collision detection. Collision padding, this is how much the software is going to keep a safe distance away from your part and jig and safety fence. All objects are fattened by 15 millimeters during transition motions to make sure that you're not going to hit the part at all. So if I were to change this, for example, I'm going to change it to 100 millimeters, then I'm sure that within 10 centimeters or 100 millimeters, I'm not going to hit anything with an extra bit of safety factor. Task tool padding, this is how much your gas cap and torch get fattened during welding and touch sensing. This is a small safety factor. I would advise to leave it at 2.5 millimeters. This is a well-tested value from us to ensure that you do not have collisions. Now, an important one is nominal stick out distance. Over here, you're able to set what stick out distance you're going to program with. So most of our customers use 17 millimeters. So in this case, 17 millimeters is what we're going to use for the programming process. You can, of course, choose 15 millimeters or 20 millimeters over here, and then that will be taken forwards for the programming process over here. We will stick to 17. And the 17 millimeter stick out is tool number 1 in DTPS for me. So you need to know that if you, for example, change it to 20 millimeters, you always need to check which tool that is in DTPS. That's how we're going to link it. So when I change it to tool ID number 2 here and 20 millimeters, I'm sure that the correct tool is going to be pulled inside of DTPS. So I'll go back to 17 millimeters and tool ID number 1. And that's everything that I'm going to change inside here in the setup tab. But now, of course, we want to look at how to place the part. So if I click on the part over here, which has got given the same name as the step file itself, we get a few selection boxes for the part itself. Again, the part parent is where the part is going to be attached. So maybe you have some dummy axes or a different station. You can change that over here. We only have the 2 stations themselves. So if I, for example, wanted to go to station 2, I could click on G6 and the part will move to station 2. Bearing in mind also that we have mechanisms. Mechanism 1 is for station 1, mechanism 2 is for station 2. So if I were to be programming in the second station, I also need to change to mechanism 2, and you can see immediately that the home position of the robot gets offset over to the second station because this is the home position of the robot in station number 2. So I will go back to mechanism 1 and G5 because we're going to be programming in the first station, and now we can look at how to place this part in a logical position. So the first thing I will do is I will rotate it by 90 degrees because I think it makes the most sense for this part to be facing upright. And then I will offset the part in the Y direction over by 1,500 millimeters to put it somewhere in the middle of the beam. And of course, you can play around here and you'll be able to find what's the correct position for your part if needed. And you have a little selection box over here for some views. So going to the right view will allow me to lower this part onto the beam logically. So I can also click with these arrows and you can see the part will drop. And what I want is for the part to be exactly on the bottom of the beam, but actually it looks like it's minus 165 millimeters over here. So of course you're also able to type the distance. So for me, this is a nice position. So when I rotate around with my right click, you can see that this part looks like it's in the middle of the beam and a nice sort of logical place for the programming process. So now what I'm going to do is I'm going to say to the software, okay, I've decided my position. I will click save. So that brings us to an end to how to put in a jig and how to place your part inside the installation. So we can go on to the next step of the training. All right, now that we've got our part placed nicely inside the installation, we've got our jig contained inside the installation, we need to start the actual programming process. So now we need to decide what we want to weld. So what you can see is in the meantime, the software has done some weld finding. So what we do is we look between all the solid bodies in the part and we look for where two solid bodies meet and we can create welds. So for example, if I click and hold with my left click and swipe over the part here entirely, we can see we have exactly 13 welds automatically found inside here. So on the left, you also get a list of the welds. They are numbered from number 1 to 13 in this case. And what the software has already done is made a rough selection of what you want to weld and what you don't want to weld. This is based on some algorithms of reachability and weldability. So these are a rough estimate of what you do and don't want to weld. So at this stage, it might be useful for you to rather look around the part and enable or disable welds. Or what I like to do is highlight all welds and I disable them. So at this stage, you see I now have no welds contained inside my part. So there's 0 welds enabled. For this reason, I can then see exactly what I'm going to enable. There are no hidden welds that are enabled that I might have missed. For me, this is the most useful, but you can of course just look around. So welds in the platform are shown as black when they are disabled, and they're shown as white when they are enabled. So if I, for example, use my left click on my mouse and I click on this weld over here, I can enable it. The weld then immediately becomes white, and the software is then saying, this weld is enabled, we will process it. Now, if I disable that again, we still have no welds enabled. And something to note is at the bottom, there's a button called View Options. And if I say Show Disabled Welds, I can hide that, and then we will see none of the disabled welds. So later, that will be useful when you've made the selection of what you do and don't want to weld. You can turn off the disabled welds, and then going further, you only see the welds that you do actually want to program. So I will turn those back on over here so that I can see what I do and don't want to program. Now I can easily just go down the list here and say, okay, yes, I want to weld that weld. Yes, I want to weld that weld, and so on. But I can also just as easily click in the platform and enable welds manually. So I'm going to weld, for example, only the outside of these 2 tubes for now. I want to weld this long weld over here. I want to weld this long weld over here. I want to weld this sort of butt weld over here. With my right click, I'll pan around and say I want to weld this weld over here, this one over here, and this one over here. For me, that is my rough selection of what I'd like to weld for this training in this very simple part, but that expands as your part gets bigger and more complicated. This will take you more time to do. Now, like I said earlier, if I click on the view options and I don't show the disabled welds, they are now gone. So when I swipe over the part over here, you see I only have 8 welds left. This will become very useful. In more complicated parts, we will find a lot more than 13 welds, so then you can throw away a lot of them that you're not using. Another thing that can be useful is if you want to look around your part in great detail and decide exactly what you want to weld and what you don't want to weld, you can hide models in this installation. So I can hide the external axis, I can hide the environmental model, I can hide the torch, and in this case, 2 Valk Welding logos. And then you see the only thing that's left in the window is the part itself. This makes it a lot easier to look around and see exactly what you do and don't want to weld, and nothing gets in the way. For example, if I turn everything back on again, if I move around here, maybe your robot or your frame's in the way of seeing what you do or don't want to weld. So that can be really useful during this process. So bear that in mind. From this stage, these are going to be the welds that I do want to program. Now, when I click on a weld on the left or in the screen, we're going to get up what's called the weld inspector. Inside the weld inspector, we can do a bunch of things to these automatically found welds. So if I, for example, zoom in here and you can see I've selected this weld on the bottom, you can see it's enabled and there's a few things we can do. The throat height is going to be the size of your weld. So this will be, in this case, an A4 weld. We do an estimate of weld thickness based on the two thicknesses of the two plates that you're trying to connect, but this you can always change, and that comes later to welding parameters. The shift start is, as you can imagine, if I, for example, want to make this weld 50 millimeters shorter on the start or 50 millimeters shorter on the end, I can do that over here. There's always a back button to undo what I've done if I want, so I can now undo back to 0 millimeters. And for example, if maybe you want to weld this weld a little bit longer on the end to get some more weld at the end of this plate over here, I could shift this end by 3 millimeters. Now this weld's going to be 3 millimeters over the end of the plate, and that can be good for welding in this specific case. So we will leave that over there. There's now a few other things we can do. That's all we will do in the top section over here. And the next section is merging. So if I go to the merging section, let's say I want to weld two welds together. You see here we have found two welds rather than one. This is due to there being a 90-degree bend there at the corner. The software is just assuming that you want to weld these as two separate pieces rather than as one. So if I, for example, want to weld this as one piece, I can click Shift on my keyboard to select multiple welds at the same time. So while holding Shift right now, I can click on the second weld, and I've now got two welds selected. So now I can merge welds. So if I click here and I click Merge, and I click off and back, you now see I have one weld rather than two. And that's really nice. But of course, our weld direction may have also changed because now we've added two here. So you see that at this end, your 3 millimeters of extra weld length are still here. So that's something to take note of. And of course, if you ever want to unmerge this weld, you can do that here. So now I've got these two welds separated again, but I'd quite like to have them as one. So I'll select them again and merge them. And you see then we get one weld in the tree rather than two. I'd quite like to do this inside weld also as one pass. So when I click merge, I've now got this one and this one. And you can see drastically our number of welds have decreased. So instead of having 8, we now have 6 because we merged two together. So that's a really nice, neat feature for merging. And the next thing we can look at is splitting. So let's say you don't want to constantly weld a weld across its full length. Let's say you want to weld this weld in 3 pieces. You can see here that I now have 3 pieces inside this tree. You see, if I click on this piece on the left, weld 6 has become weld 6.1, 6.2, and 6.3. So you now have 3 pieces instead of 1. If I want to ever unsplit this, you see that now I can't split this back to 1 because I could just as well split this split of 1 weld into 3 again. Then I get weld 6.2.1.2.3. So you see it goes down as sort of a parent and child relationship over here. So if I want to unsplit this, you see weld 6 has become split 6.2. So if I click on weld 6 over here, we go back to the original length, full length weld, and I can go back to 1. So that's one way that you can unsplit the weld over there. Could just as easily have used the undo button, but if you've gone and done other things and you want to go back, that's a little bit more difficult. Now the split amount is going to be 3, and the split coverage is how much of the length of the weld is going to be welded. So if I change this to 40%, 40% of the total length of the weld will be welded in 3 pieces. So I could just as easily make this 70%, and you can see the gaps of no weld will grow. And if I make it lower to 10, you can see the gaps of weld will shrink. So that's quite nice over there. I don't particularly want to split weld this weld in reality, so I'm going to put it back to 1, and then that is what I'm going to have over here. So this is actually everything that we do in the design phase of our welds over here. So we can actually move on to the next phase. We've decided what we want to weld. The next thing we're going to do is decide how we want to weld. So I will click Save. I'm now telling the software, these are the welds that I want to weld. I click Save. It's going to now take the processing further. Now one of the steps of processing. So next section, we will talk about the second tab, geometric parameters. All right, now that we've done our design phase of the process, we're now going to look at how we're going to weld our welds. We decided what we want to weld. Now we're going to decide how we're going to weld it. So if I select a weld over here, our weld inspector will appear again on the right. And if I click on the geometrics tab, we get another bunch of information that we can look at. So now at the top, starting at the top, there are a few things that we can do directly. The first one is we can invert the direction. So the software has decided we're going to start over there and end over there, but we could just as easily do it in the other direction, start over there and end over there. This is sometimes important during the programming process, so that's something that you can change if you want. What the software will do is it will look in both directions and decide for you which it thinks is the best direction. But if you ever do want to invert it, you can click that button over there to invert it. I will leave the weld in the direction that the software chose because I think in this situation, there's no reason to change it. The next one is tack welds. Here, for example, we can add tack welds to this weld. And if I zoom in really close, because this is difficult to see, you see we're going to add a tack weld here at the beginning. We've said we want to add 3 tack welds of 2 millimeters length at 50% of the weld thickness of the total weld at the top. So if I change this, for example, to 2, we will only have a tack weld at the beginning and end. And if it was 3 like it was before, we will have a tack weld at the beginning, at the middle, there's the little one, and at the end. This is only really useful if you have a really complicated jig where you put the parts in and the robot's then going to tack weld the entire part together for you. And you see that tack welds start with a T, and these are going to be tack welded all before the welding process. So here, we're not going to tack weld, so I'm going to turn that off. So we're going to go back to just only our welds over here, and we will leave that. The next thing we're going to do is look at sense motions. Now, if I click and adding a sense motion for this weld, weld number 3, we get S for sense motion 3. So weld 3 is linked to sense 3. Now that's how we're going to build up our program tree on the left here. And at a later stage, I'll show you how you can do your sequencing of your program. I can decide here then between start only or all points. So all points is actually more than only start touch sensing. So in this case, it will touch sense at the beginning, at this corner, and at the end. On a straight weld, it's usually beginning and end. If you have a weld with straight, corner, straight, there's going to always be touch sensing at the corner as well. This is because your weld orientation or your torch orientation is changing quite a lot. So in this case, you'll want to touch sense more than only the beginning. So for this weld, we will say we want all points, but actually maybe it's easier if we go to this entire program here and we say under geometric, we want sense motion start only for all of the program. You then see all of the welds over here get a sense motion block. So if I click again on a weld, I will say, okay, for this weld, I want all points. For this weld on inside, I also want all points. So I'll change it to all points because there's a bend. And for the rest, I'll take only start only. For a circle, it's important to use only start only touch sensing, because for start only, you'll see we do circular touch sensing. So we'll touch sense the front, the back, the left, and the right of the circle and the height. And then you will get touch sensing loaded from the center of the circle to the entire weld over here. So it's important on circles to have only start only welding. Now, the next thing we can look at is an arc start motion. So let's say you have a weld that starts on top of another weld. If I say I want an arc start motion, it simply gives you a distance. And this means, to make it clear, I'll change it to 10 millimeters. The weld will start 10 millimeters from the start. It will then go quickly, much faster than your weld speed, back to your original start position and then continue welding. So maybe you have a tack weld over here and the robot's going to struggle to light the arc on that tack over there. You then can do an arc start motion that to make sure that you're not going to start on top of that tack and have arc start issues. So that's a nice feature over there. But again, in this case, we're probably not going to need this feature, so we won't use it. Now, the next feature is offset. So if I take a look at maybe one of these welds on the inside, offset will become more clear. So if I want to offset this weld, so for example, 5 millimeters, I'm then going to offset it 5 millimeters outside of the corner to the right. That's along the one plate direction. And if I were to change it to 5 millimeters on this side, I can offset it 5 millimeters on that side. If I want to offset it exactly out of the corner of the weld, I can add that to both. So that's 5 millimeters along there and 5 millimeters along there. Now, of course, the distance isn't exactly 5 millimeters out. You need to do a little bit of trigonometry to calculate what that distance is, but it'll be a few extra millimeters than 5 millimeters. Again, in this stage, I don't really want to offset this weld, so I'm going to leave it in the corner. An important thing to note is that offset does not work for merged weld parts, because of course, merged weld parts are more complicated to shift than weld parts that have not been merged. So that's important to note. Now, also on circular welds, you'll see that this feature also works. So for example, if you want this weld to be 2 millimeters up or 5 millimeters out, your entire circle will grow. So that can also be used for circular welds over here. We will again leave it in the corner. Now under travel and work angle, we're then going to look at your torch position. So we are going to push this weld with 10 degrees. So that's the angle between the wire and your weld direction. So here we will push with 10 degrees. I could just as easily pull with 10 degrees. That's not very good for welding. So you probably won't do that unless you are maybe welding down, for example. Here, these settings are up to you how you want to weld. But there's always a default value, and that default value is pushing with 10 degrees. And if you actually have a look in the setup phase and the motion planning, you'll see we can set up the default push angle. So if you ever want to change the default push angle for an entire part, for example, to push all of these welds with 5 degrees, you can then do that over here, and all your welds will by default have 5 degrees. That's a nice feature. I'll go back to this weld over here. You could, of course, just as easily highlight over all of the welds and say, I want to push all of the welds with 5 degrees. So that can be done nice and easily over there. I'll leave it at 10. Now, the next one is work angle. So in the geometrics tab, we look at the work angle. It's at 0 degrees. So that is actually the wire direction in the weld. So you'll see these little lines indicate the wire direction. So here the wire direction is directly in the middle. 0 degrees is the middle of the two plates. So you could just as easily make it 20 degrees lower, or with -20, you could make it 20 degrees higher. So this feature is useful for when you're maybe welding a thick material to a thin material and you need to bias the heat a little bit more into the thick plate. You can, of course, do that over here. So zooming out again, we need to look at the external axis settings last. And for the external axis settings here, you'll be able to see what position has been chosen for this weld. Now, the G4 axis is the track axis in this stage. You may have more axes if your robot's mounted on a 2-axis track or a 3-axis track, or no track at all, then this G4 won't appear here. And the G5 is your manipulator. So if I were to change this, for example, to 20 degrees, you see that weld's entire position changes over to 20 degrees. We would quite like to leave that at 0 degrees. Now, what you'll see is for each weld, the software has actually already calculated the position for this manipulator. So that weld is automatically calculated over to 90 degrees on this manipulator to be under the torch, to keep gravity facing down. And of course, on all of these horizontal welds, it will actually be left at 0 degrees over here. Like you saw, it's just as easy to change this to 90 degrees or 0 degrees or 10 degrees. This can all be changed over here, but I would quite like to leave this one at 0 degrees over here. Now for the G4 position, if I leave only enable coordinated motion, that means that the track axis is allowed to choose whatever position it wants, and it's also allowed to move as much as it wants during welding. So if I disable coordinated motion and I set the position, I'm actually allowed to set the position for this weld. So we're not going to let the software take care of it. We're going to set the position ourselves manually. And you can see I could choose 907 millimeters. You say to the software, only program this weld with the track fixed at 907 millimeters. That then takes away a degree of freedom for the software. I will not do that. I will say, let the software take care of this. So I'll say enable coordinated motion and turn off start position. Now, coordinated motion for the G5, this is your manipulator. You can just as easily allow the rotator to move during welding as well. And this only really works when you have a circle that needs to be welded at the same time as rotating. So in this case, there are no welds in this part that need to be rotated and welded together. But for example, for this weld at 90 degrees, I could enable coordinated motion. And if this weld were to be circular, the software will calculate over the entire length of the weld the manipulator position moving at the same time, and will calculate that rotating and welding position for you. So we could say start at 85 degrees and maintain that same position for the straight weld. It will stay at 85 degrees the entire length of the weld, but you can do that there. So experiment with that on a part that needs synchronous movements or harmonic movements. These are other names for coordinated motion. So what I'll do is actually put this back to 0 degrees, and I will disable coordinated motion. Sorry, 90 degrees actually. Change it to 90 degrees where it originally was, and you see it actually changes back to green because then I've not edited this weld at all. So that's nice. That's actually, I think, everything we need to do under the geometric tab over here. So there's nothing more to change about how we want to weld. So again, I will click save, and then we're going to say to the software, please save this part. Now calculate with any changes that I've made. What we do have though is we have two welds that have appeared as red, and the software is saying that this path is infeasible. Now this weld needs to be done under the robot, so what I'll quite actually like to do is just invert the direction, and this weld over here we have a problem. So I'm not sure why. It's probably at yeah, minus 90 degrees, where maybe the robot can't actually reach all the way over there. So what we can do is maybe change this to minus 60 degrees. And if I click save, then the software is going to calculate that weld at minus 60 degrees. So now we can be sure that the software is going to go away. It's going to calculate all of these welds. If they all come back green, everything is good, and the welds are reachable, programmable, and there is a program existing. The last thing that will get done is once the welds are all calculated, the touch sense positions will all get calculated for you. So now some calculation is running in the cloud. So all the computations taking place in the Google Cloud, we're actually not doing anything up to this point. The software is taking care of everything. But if a weld has appeared as green or yellow, for example, this green weld over here, we do actually have a program existing already. So if I click play, you can see a simulation of how this weld is going to be programmed. So you'll see at the end here, the software is already calculated. You need to turn the torch to make sure you don't hit at the end of the weld. So it's a really nice way to check the simulation already for you over here. So that's nice. We will take a short pause to let the calculation take place, and I'll come back to look at the next section of the programming. Now that we've decided on the geometric parameters, so basically how we want to weld this, looking at manipulator position, weld direction, etc., we're now going to look at our process parameters. So if I click on a weld over here and I click on the process tab, you're going to see that some weld parameters have been assigned to each weld. So what the software has done is it's pulled out of a standard base of welding, a welding table, and looked at the thickness of the weld and the required weld thickness, which you put up in the setup phase. That can then be checked inside here. So of course you have your voltage, current, speed, we have weaving, crater fill, and pulsing. So this can all be taken care of here inside the software. So for example, on all of these welds, since they're all sort of horizontal welds, we could highlight all of the welds, for example, with shift key on the left here, process, and we could say, okay, we want 28 volts, we want 290 amps, and we want 0.5 meters per minute. So you could easily apply a welding parameter to all of the welds at the same time. You could also let the software take care of the welding parameters for you and then adjust them on the robot based on what the result is. But I would suggest that you put in the parameters yourself, because you should know better than I do how the product should be welded together on the robot, since it obviously depends on wire, gas, the material, all of these things matter. So you should know your welding parameters better than I do. Now, what's nice is you can see all of these welds have got a program, including, of course, all of these circular welds. Something you can also see here, for example, is that this weld's been started underneath the robot. If you ever need to change the starting point of a circle, you can see there's this last tab that I didn't describe yet, which is the circular start offset. I wanted you to be able to see that the weld starts underneath the welding arm itself, the robot arm. So if, for example, you want to start this 25% to the right, or maybe minus 25%, you can then start the welding position of a circle in a different place. This also applies to welds which are square, for example. This is also technically a circle, so you can change with the circular start shift over here to a different position. For example, 25% is the other corner. These types of things you can still change based on circles, but you need knowledge of how the robot is going to act when you change the starting point of your circle. So if I come over to process, you see we've now set our process parameters. In the advanced section of the training at the end, I'll talk about how we can do welding tables from DTPS, and that will become more clear with a little bit of training from us how we can do that. That's not something we will describe in the training today, but at a later stage, or if you do use welding tables in DTPS, get into contact with us and we can describe much more in detail how we can do that for you. Now that we've looked at process parameters or weld parameters, the last thing we need to look at is the sequence of our program. So here you can see the software has finally given an automatic sequence of this program. We've got a default sorting strategy in this program, and this sorting strategy is by gravity grouping, it's called, which means all welds at the same manipulator angle will be put together. So all of these welds from the top will be put together, and then gravity 2 is the weld on the side, and gravity 3 is on the other side. So this strategy reduces manipulator movement, so how much the rotator is going to rotate during welding, and that can be adjusted over there. So now you can see, for example, if we want this weld to be last in this section, I can simply drag and drop it to the end over there. If I want this weld to be first, you can see all of these blocks are just nice blocks that we can drag around in this section to create our sequence. So very easy for you. If you want to touch and weld every weld, you can of course drag like this to do touch and welding, touch and welding. So it's very simple here to change to touch and welding if your heart so desires. Then we won't be using these gravity groupings like you see here. But now, of course, if you're going to do touch and welding, you will know that it's important to cut your wire. Every time you weld, your wire is going to melt back, and then you cannot touch sense with your wire tip. So at this stage, it's important to put in what's called a subroutine. So if you look in DTPS over here, this installation has a bunch of subroutines, for example, a wire cut. So if I were to take this program without the .rpg, I just need the name of the program. I can create a new subroutine. Every subroutine can get a name, for example, wire cut 17 millimeters. This name doesn't matter, it's just visualization for you, but the script needs to be exactly the name of the program in your robot controller, because that's the program that's going to get called during your program. So if I click save, we now have a sorting strategy. And now every time after we weld, we need to add the wire cut, sorry, a subroutine wire cut. So after each weld, add wire cut, after each weld, add wire cut, and one more, add wire cut. And of course, there we are finally done. So we obviously don't need a wire cut after our last weld because we're just going to go home and we're done with the program. Maybe it's important also at this stage, we want to do a mechanical cleaning also at the beginning. So here you can set up what your subroutines are. So I'll add another subroutine and I'll call it mechanical cleaning. And I will put exactly the same script there as what's in the robot controller again. And at the beginning of my program, I will add mechanical cleaning and I'll add wire cut. First clean, then cut. That's normally our process over here. So here you can see then we're going to clean, cut, and then do touch weld, touch weld. But now I'm going to undo all of this because really we actually don't want to cut and clean every time that we're going to do this. For this part, it's okay to touch sense the entire part, then weld the entire part. So I'll have to just manually add my sequences back here because I deleted them in the going back and undoing. So then I'll grab just my wire cut program as well. So I'll add then again my wire cut program. And then for this program, we will add wire cut and we will add mechanical cleaning. Again, first mechanical cleaning, then wire cut. So that's how we're going to do that over there. So this will be our final program. This is now, I'm happy with the sequence, I'm happy with the welding parameters, I'm happy with the weld directions, I'm happy with what we're welding, and I'm going to click save. Now, finally, the last stage of calculation is going to take place. So any changes that have taken place are going to calculate. So for example, we now have a transition from our wire cut to our first program. And if you expand these, you see that we have between every weld, we have a transition. So this transition is actually already calculated. So what we'll do is we'll give, again, the software a second to catch up with all of the calculation. And the last thing that we're going to do is we're going to download the program. And once we download the program, we can upload that into DTPS and we can make our own edits in DTPS, or we can send it into production. So this is our final stage. The calculation sitting on 66.7%. So we're going to take a short break and let it finish off the calculation, and then we should have a program to download. Now that we've finished programming our product and we've given the software a couple minutes to do the calculation, you'll see here now that the full program is done calculating. So we do have a warning here, that is that these welds will have a potential cable management issue. So the welds that appear orange are saying that there's a potential cable management issue, and that's quite understandable in these circular welds because we're going to have our cable going completely under the robot arm. But there's really nothing we can do about that in this weld. So it's giving you a warning and saying, when you put this program on the robot, please do take care that the cable management might be an issue. So you might need to take some action, whether that's on the robot or in DTPS, to avoid this. But I would suggest trying it out on the robot and checking if there is an issue. We already do our best to minimize the cable stress. But in this case, we've said this is the best we can do. We're saying to you there might be an issue. So please just take care when you put it on the robot. But in my experience with our newer robots and the stronger cable assembly, things should be okay. So what we can do now is when we want to download our program, we click on the word program over here. We then get a new tab on the right called program, logically, and what we get is robot program files. Now that the calculation's done, there is actually a program to download. You get a direct cycle time. So in this case, it's giving an estimate of 3 minutes and 20 seconds for the total length of this program to run on the robot. But what we're after here is the program. So if I click program.csr, program download gets downloaded to my PC. So now I have a .csr file on my computer, and we can now jump over to DTPS. So at this stage, you're done in the ArcNC software, and you're going to go over to DTPS, and you're going to use this program in the normal manner onto the robot. So I'll jump over to PC tool, and I'm actually already in the right place. I'm going to go to training, and I've got a completely empty group and object over here. And I'm going to right click under the robot tab and say import CSR file. Once I've imported the CSR file, we'll take the most recent one from right now, and we will click open. It's going to ask us, do we want to execute the conversion? I will say yes. It's then going to process the file. There are some welds with bad parameters because of us not putting the parameters in the butt weld, but if you ignore that, you'll see the program then comes up. There are no errors inside this program, so I'm going to open it. I'll say I'm going to open the program, and then it opens inside DTPS. So DTPS window loads up with the installation, and you see we have a program on top of the beam, but the workpiece is not in here. So what we're going to do is we're going to go back to PC tool, to independent or group or object folder, wherever you want to store your part, because the step file is not automatically imported for you. I'm going to click on new, and we will create a new part window over here, and I will just simply say file, import CAD file, and then under the exact same part over here, I'll upload the same step file. It's important that you upload the same step file and you do not manipulate its position. So I'll click save, and it will become clear in a second why we do not manipulate its position. And now we have a part in the independent folder. So if I go back to my program over here, and I double right click in the normal manner of inserting a work product over here, you see the exact same position that we put inside ArcNC is contained in the file already. This is important because then when I go to the independent folder and I add the part and I click OK, the part is already offset and rotated to the exact right position for this part and this program. Now you can see in the program on the left, we've created quite a lengthy program inside here, and everything is inside there for you. So we've got mechanical cleaning called, we've got the wire cut called, it's at the home position first, cut, it's going to clean, cut, and then go after the program. And at the end, you'll see the program also takes everything home right at the end. This is now completely collision free. As long as everything's defined perfectly, it's basically ready to go. So if I click F5 over here and I simulate this program, we get a normal DTPS simulation. Now maybe 20 is too long, so I want to simulate this a bit quicker. So you can see the program is going to simulate in the normal manner that a lot of you are familiar with in DTPS. So that is essentially the programming process and the training from beginning to end for basic training. You can do whatever you want in DTPS from here. This is the normal programming manner that everyone should be used to. And in the next section, we will come to some more advanced features of the software, which should not be used for the most part, but in some cases are needed. So please follow on to the advanced section of the training if you feel that's necessary, but I would suggest just watch it anyway, and this might be used by you at a later stage. Now that you've followed the basic training, we're going to go into a few advanced features. These features are a little bit more complicated to use, but might come in handy at a later stage. So the first thing I'll start with is the DTPS Weld table. So you see we have our program over here. Now what we can do is, for example, if you're familiar with the DTPS Weld table, over here you see I've set up 4 weld parameters over here. So what we want to do is, instead of having to pick individual weld parameters like voltage, amperage, and travel speed, we can just select a weld job number. So we can say, for example, I've tested this main parameter. It's 240 amps, 24 volts, 0.4 meters per minute. There's also some kind of section sequence contained in here, some other commands contained. This is all neatly inside the DTPS weld table. So what we can do is if I go back over to ArcNC, we need to be able to import this weld table. Now, if you do use weld tables and you're looking to use this feature inside ArcNC, please get into contact with us because there's a little bit, it's not super easy to export the weld table. So we'll have to teach you that in the follow-up training session. But for now, I'll show you how it's done so that you can come back to the video if you ever need to see how to do it. What I'll do is I'll go to the setup stage over here, and I need to go to the post-processor settings. Now, there's a lot of things in here that you don't necessarily need to touch, but if you look under power source, we can change it from default to Panasonic, and then a button called import welding table appears, and here we can import a CSV file containing our DTPS weld table. Again, please contact us and we can show you how to create the CSV file. But once I click open, the nice thing is now I have only 4 parameters. So these are going to be identical names and job number to what is going to be shown over here. So now when I look at a weld, for example, and I go to the process tab, there is the main parameter and 2, 3, 4. So you now can just select from a database of weld parameters that you've tested rather than individually selecting each parameter each time. So this is a really nice feature. You can obviously, of course, swipe over everything, or in this case, without the touch sensing, we can go to process and say, I want all of them to be main parameter, and maybe one of them, for example, this one over here, we want this one to be 45-degree weld or whatever. It's not super important at this stage, but you would have named them in a useful way. You know what to reference it to. So that at this stage is how we are going to do the DTPS weld table. So the last thing I'm going to show you is another advanced feature, and that is for touch sense editing. So if I expand this touch sense box over here, we really don't see anything. But if I want to do a little bit more with how to edit touch sense positions, I can click on the little question mark over here, and I need to enter advanced mode. If I enter the advanced mode, there's a couple more settings that appear. These, again, are default settings. Please don't change them. But if I click on Sense Group over here, you now see that I have 1, 2, 3, 4 touch sensors. Let's start with maybe a slightly simpler one over here, not a circle. If I click on this one over here, Weld 11, if I go to Geometric and Sense Motions, there's actually a Go to Sense Motion settings. And that will actually jump to sense number 11 for me. And now we will see that we have a beginning touch sense for the straight weld, and we have an end touch sense for the straight weld in 3 directions. And when you click on each of the groups, you'll see that there are 3 senses and transitions, but it's easier to leave the box over here collapsed. Now what you'll see is if I click on sense number 1, for example, that is the first one, that is the second one, and that is the third one. Now, if you, for example, want to change these touch sense positions, let's say we want this third one to be slightly higher for whatever reason. The third one over here, if I pick a sense motion, I can actually move it. So if I move it now over here, that other one will disappear, and that's where that one's going to be. I can move my first one a little bit further away, and I can move my second one a bit further away if I want to. Now you can see each of the sense motions actually come with a sort of size around it. And now since we're going to touch sense 12 millimeters, what we've done is we've created a circle that's 2 times 12 millimeters. So you actually can't place this first touch sense too close to a plate because it's your first touch sense. You don't know where you are. So you could end up hitting the plate by accident during this first touch sense. Or if you put this one on this first face over here, you don't know if you're going to miss the plate. So use these as a guide to look for a space big enough to create your touch sensor. So the first one's big. The second one there is then flat because we found our vertical offset. So that one's flat. And your third one is just a dot because you've lost 2 directions of uncertainty and you've got your last one over here. So this one can be very useful because these touch sense positions have been automatically found. So maybe the automatically found touch sense position isn't good, or you don't think it is good. You can always change that over here. So if we look again at the third one over here, sense group number 2, we can also change these positions. So it has decided to touch this face first, this face second, and this face third. You can change that over there if you want. You can also get rid of all of the sensors and you can pick them all manually. Let's say we want to do the Z first, we want to do the side direction second, and we want to do this direction third. So you can just as easily change what the software is going to do over there. So that's touch sense point editing. What I'll do is undo all of my changes because I'm quite happy with the default automatically found ones at this stage. And that is everything that you can do with touch sense editing. And the last thing we will look at is something called individual points editing. This one's a little bit more complicated, but if I take, let's say, this weld over here, when we are in the geometrics tab, you can edit the travel and work angle for each point. So if I want my travel angle to be 10 degrees pushing at the beginning, but I'd quite like to end on 10 degrees or 20 degrees. If I go to my last point, there are only 7, and we look over here, that will be the end is my last point. I can quite easily say I would like to push with 50 degrees. And now at the end, I'm saying the end point of my weld, I'm going to push with 50 degrees. And maybe it's nice to see at the beginning in my first point, my first waypoint, I'm going to say 10 degrees of push. That's the original. To make it a bit more obvious, you see if I change that to 50 degrees of push, the first point is now pushing with an extra 50 degrees. This feature is really not used a lot for changing your push or pull angle. It's definitely used a lot more for your work angle. So your first waypoint is going to weld with the torch in the middle. And for whatever reason, you may want to change the angle in the middle of the weld. So if I go to individual points and I say I want to be 10 degrees lower at my first point, you see then it's going to go down by 10 degrees. Your first point's actually on the other side because your direction was inverted. So that's at the beginning. So if I change to my 7th waypoint over here, oh, sorry, second, there's only 2, then I can change that my work angle at the beginning is going to be 10 degrees lower. Or maybe I want to have it at 20 degrees higher. And now you can see the torch is going to start 20 degrees higher and lower towards the end. So this is a very sort of advanced feature that, again, is not used that much. So please use it with care. If you really need to use it, contact us. We can also help you to use this feature, but this is the basic functionality of the advanced mode. I would highly suggest that you do not stay in the advanced mode, because if you are in there, there are always much more boxes. So now that you're in here, that's dropped away. So we're trying to keep it as simple as possible. So that concludes the advanced features section of this training, and actually concludes the training altogether. So I'd like to wish you all luck with using this software. If you need to contact us for any support or help, please contact us at arp@valkwelding.com. That's automatic robot programming at valkwelding.com. That is handled by our entire team. So we try to answer questions in there as much as possible and as quickly as possible. So if you ever need help, please do contact us there at arp@valkwelding.com. Thank you for your time, and good luck.